Okay, so now we're going to do the oblique asymptotes of rational functions. These are also known as the slanted asymptotes of rational functions. First thing you need to notice is that the degree of the numerator is exactly 1 more than the degree of the denominator. So this was degree 2 and this is degree 1. Exactly 1 more. Now, if that's not the case, then it doesn't even have a slanted one. It has to be 1 degree more in the numerator than in the denominator, or it doesn't even have one. So, once you see that this is the case, then the way you find it is through division. You find the oblique through division. Now, either long or synthetic. Now, the only ones I'm going to give you can use synthetic, but understand that you only get to use synthetic with a binomial denominator. If you have a second degree denominator or a third degree denominator, you have to use long division. That's another mess that we won't go into right now. So here we go. We'll just do this one. Alright, so I'm going to do synthetic division with these guys. And so the first one is a 3 and a 0 and a 7. And I'm going to divide by 2. Remember, there is a sign change there. I will bring down the first number. And 2 times 3 is 6. And 0 plus 6 is 6. And 2 times 6 is 12. And 7 plus 12 is 19. Now, it doesn't matter that you don't get 0. Don't expect it. This represents 3x plus 6. You don't need to worry with that number. Now, if you'll recall, a slanted line is in the form of y equals mx plus b. So, y equals 3x plus 6 is a slanted line, and thus this one is our asymptote. This is our slanted or oblique asymptote. The second one works the same way. We'll use synthetic division. And we'll divide by the -7. Bring down the first number. We'll multiply. We get -42. We add. We get -46. And it doesn't matter what that is. It doesn't matter what that is. I'm not going to do that multiplication. This is 6x minus 46, and that is your oblique. Okay, so on these two examples, we're going to find all the asymptotes, if they have any, and that's a key part, if any, because they might not be one. So we're going to go through each one and check. First, we'll do vertical. The vertical asymptotes can be found by setting the denominator equal to 0 and solve. And so I get x equals -5 for my vertical asymptote. And yes, you must type in x equal -5 on your homework. The horizontal asymptote, you look at the degrees. It's big on top, therefore there's no horizontal asymptote. And that's just what you'll put, or you'll click the option that says there's no horizontal asymptote. Now the oblique, you look at the degrees again, and notice we have a degree of 1 more in the numerator than the denominator. So we are going to do the synthetic division. I'm going to have a 1, a 0, and a -7. I'm going to divide by -5. Bring the 1 down, and then I multiply and add, and multiply and add, and it really doesn't matter what's over here. This is 1x minus 5. My oblique is y is equal to x minus 5. So we found all of them. This next one, we're going to do, again, we'll do the vertical asymptotes first. We're going to take the denominator, set it equal to 0, and solve. I'm actually solving this one because I need you to see something. Square root both sides, and I get x is equal to positive and negative I square roots of 2. Well, this is imaginary. This is a complex number that we're not going to graph. So there are no vertical asymptotes. There are none because we got an I when we solved it. So now we'll go to the horizontal. Again, the horizontal rules, those rules are on a previous video, so check those rules again if you need to look over them. We compare the degrees. We have a 3x to the third, x to the second over an x to the second. They're the same degree. So we go to the coefficients, which are 3 and 1. And so my horizontal is y is equal to 3, technically 3 over 1. And that is my horizontal right there. Now, if I have a horizontal, then I don't have an oblique. You can't have a horizontal and an oblique at the same time. So just remember that. So there is no oblique. Okay, so now these are the last problems on our homework, and they say graph the rational function. Now the graph part of this is multiple choice. So really all we have to do is determine the vertical asymptotes, the horizontal asymptotes, oblique, and then plug in a number to see if it works. And so what we're going to do first is we're going to do the vertical asymptotes. And so we set the denominator equal to 0. We get x squared equals 4, so we get x is 2 and x is negative 2. So on my graph, I'm looking for a multiple choice graph with a vertical asymptote at 2 and negative 2. All right, now horizontal asymptote would be next, and it's big on bottom. So this one is y equals 0, has a horizontal asymptote at y equals 0. That's the y-axis. So that's my horizontal asymptote. I do not have a slant. So now, to pick for my multiple choice, I'm looking for ones that looks like this, and I'm going to plug in some numbers to see what happens. So I'm going to plug in 0 for x. I can do that. So if I plug in 0 for x, I get 0 for y. So I have a point at 0, 0. Let's plug in another number. If I plug in, say, 1 for x, I'm going to get 7 over negative 4 for y. So if I put 1 for x, I'm going to get a point somewhere down here. If I put negative 1 in for x, I'm going to get negative 7 over negative 4. I'm sorry, negative 3. My bad. Hold on, that's not right either. I get negative 1, plug in 1, I get 7 over negative 3. Plug in negative 1, I get negative 7 over negative 5, which is 7 over 5. Okay, and so I'm probably going to have a little thingy that looks something like this in the middle. Okay. Now, if I plug in 3, I'm going to have 21 over 5. So if I plug in 3, I'm going to get 21 over 5, which is 4 and a fourth. So I'm a point right here, so I'm looking at, oops, I missed. Let me try again. Something that looks like that. Just going to run my asymptotes. And if I plug in a negative 3, then I will probably get a negative 21 over 5. So probably down here, and it's going to run my asymptotes as well. That's what the asymptotes are for. And so look carefully. Again, this is multiple choice, so you shouldn't have too much trouble figuring out which problem it is. The next one's a little bit easier, and I'm going to try to hurry because I'm already over 10 minutes. I'll try to keep my videos short. So my vertical asymptote is going to be at x equal negative 5. Okay, and that's the and then my horizontal, I have a horizontal at 0. No, excuse me, at 1, because the degrees are the same. So there's my horizontal at y equal 1. Okay, and so now I'm just going to plug in a couple of numbers, and if I plug in 0, I get 2/5. So that's 0 2/5. So that's going to be right here. If I plug in, say, negative 6, now why did I pick negative 6? Well, I plugged in 0, so I'm going to get this section right here. And so now I've got to plug in a number to get something on the other side of that vertical. So let's plug in negative 6. Plug in negative 6, I'm going to get negative 4 over negative 1, which is just 4. So I'm up here. So then I'm going to look, again, following my asymptotes. We'll get something that looks like that. And following the asymptotes, we always follow our asymptotes. So there you go.